Welcome back guys, JimmyJules153 with another Dreams Logic tutorial. First, just a quick update on the fighting game project I've been working on. It's a 2.5D fighting game, where your objective is to kill the player off by dealing damage, or by knocking them off the screen. It's got a camera system that can track anywhere from 1 to 4 players, and zoom in on them when they get closer together, just like the Little Big Planet camera. I'll be covering different aspects of this and how some of it works in future tutorials, but today we'll be looking at the Advanced Mover. The Advanced Mover is a gadget you can use to manipulate an object's movement on the X, Y, and Z axis. You can see this cube is able to move left, right, up, down, and in and out, all with only the one Advanced Mover. We'll jump into our microchip on the block here, and first of all I'll take you through some of the properties on the tweak menu. You can see here that we've got our X-axis movement set to 5 meters per second, and that we've got the value slider plugged into this. You'll notice that the tag that pops out of the side of the tweak menu that we've got our value slider plugged into has an X on it. This means that the wire blend is set to modulate. You can change this by holding Shift and hovering over the tag on the tweak menu, and you'll notice it turns black. If you select the tag while you're holding Shift, you can change the wire blend type. Modulate will take the number that we've got our slider set to, so 5 meters per second, and multiply it by the signal that we're inputting. This means that if we're inputting a signal of 50%, it'll multiply our slider set to 5 meters per second by half, so we'd get 2.5 meters per second. You can see that when our value slider is set to 1, it gets set to 5 meters per second, and as we decrease it, the slider decreases with the signal. It's important that you have your wire blend type set to modulate, otherwise it won't take into consideration the value you set on the slider. If you've got it set to the override blend, it'll disregard the speed that you've set, and instead adjust it to the signal that it's receiving. You'll see this in just a sec. The blend option will do the same thing as the overwrite, but if you've got multiple gadgets plugged into the one tweak menu port, it'll average the signals it's receiving and set the slider to that. You can see that if we set the blend type to either blend or overwrite, that it disregards what we set the speed slider to. When it's got a signal of 1, it'll set the speed slider to 0.1, and if we gave it a signal of 2, it'd set the speed slider to 0.2, and so on. There's a lot of inputs that have these blend types, so keep an eye out for them, as they can eliminate unnecessary gadgets and unlock new uses for existing gadgets. We'll jump into our main movement chip for the cube now and go through the setup. We've got a controlinator here that's set to remote control, so we don't need to possess it. And you can see that we've got our left stick plugged into a splitter, which is splitting the joystick into up, down, and left-right movements. The X port is left-right, and the Y port is up-down. We've got each of these tweak menu inputs set to modulate, so we can choose the speed that it goes. You can see that when I slowly press the left stick right and left, the speed slider gets a positive signal when we push right, and a negative one when we push left. This splitter is outputting a positive and a negative signal for each of the ports, for the left-right signals and the up-down signals. If we plug the up-down signal into another splitter, we can get the positive and the negative signals from different ports. You can see that for some reason at the moment, up on the stick seems to put out a negative signal and down puts out a positive signal, which is a bit strange and this might change in an update. To get around the cube having this inverted effect, we've wired in a joiner. We've plugged the positive signal into the negative input, and the negative signal into the positive input. This is just basically swapping the up and down movement. We've then got this combiner plugged directly into the Y-axis speed. For the in and out movement, we've got this hooked up to the triggers. Because the triggers both output positive signals, we need to make one of them negative so that it can move the cube backwards. To do this, we've just got the left trigger wired into a combiner's negative port, and we've got the right trigger plugged into the positive combiner port. Because the sticks and triggers output percentage signals, the harder you push the triggers, the faster it'll move in and out. And the further you press the stick, the faster it'll move around. We've also got the usual dampening settings for each axis, which will affect how quickly the cube slows itself down again after you stop giving it a signal. Finally, on the Outputs page is the affected object output, which you can plug into an object to make the mover affect it. But this will happen automatically if you snap the gadget to an object, like we've got our microchip snapped to the cube here. That's all for the Advanced Mover, guys. Hope you enjoyed the video, and I'll see you in the next one.